Have you ever wondered why icebergs are made of fresh water even though they float in salty oceans? It's not magic, it's science. When seawater begins to freeze, the ice crystals push out all the salts, and it's nature's way of separating solutes from water. Our innovation is called Purification of Water into drinking water through ice crystallization.
Here's our research members, myself, Dr. Zaki, Mr. Hao Chee and Afiqa Nabihah. This project adapts a simple ice-making unit to perform progressive freeze concentration or PFC, transforming roof harvested rainwater into potable water. By gently freezing the water on a cooled surface, pure ice crystals form, excluding dissolved solids, color-causing organics, and turbidity. The thawed ice then becomes safe and clean drinking water. What motivates this project? Because the rain is abundant, but storage and treatment is limited, and the roof harvested rainwater carries dust, leaf debris, and microbial load, resulting in costly first flush and filtration system. Our innovation is a low-cost, low-maintenance purification step that could fit between the gutter and the tap. Principally, in this process, liquid water is cooled down to below its freezing point. Water molecules will start to arrange in an orderly crystal lattice to form solid ice. Under optimum conditions, only water molecules can attach to the growing ice crystals, and this enables the formation of very pure ice to be thawed as drinking water afterwards. Our key innovations include: 1. Adapting the natural ice crystallization process to freeze-purify rainwater. 2. Repurposing falling film ice maker for PFC. And 3. Optimizing two variables, which are circulation time and feed quality, to achieve over 93% total dissolved solids removal and color reduction to within drinking water limits, all in a compact footprint. The experimental setup consists of a rainwater tank that stores the harvested rainwater, which will then be fed to the sump tank to be circulated on the cool surface, distributed evenly by a distributor. The produced ice will then be collected in the ice tank to be thawed as drinking water. To begin the ice crystallization process, the sump tank is filled with rainwater via an internal feed pump. Once full, rainwater is circulated through a distributor on top of the cooled surface using a circulation pump. Rainwater flows down on the cooled surface as a thin film of liquid and gradually cools down until ice crystal forms on the cool surface eventually. After 20 minutes, ice cubes formed are detached from the cooled surface and collected in the ice tank. The ice can then be thawed to produce clean drinking water. All rejected contaminants will be in the purged water, and we will get the drinking water from the ice. This innovation will contribute to SDG 6 as our PFC approach will 1. Reduce dependence on centralized treatment and long supply lines, 2. Minimize chemical disinfectant used, and 3. Empower off-grid communities and small-scale buildings to meet WHO and local drinking water quality guidelines. As far as commercialization potential is concerned, this technology lends itself to 3 main markets. 1. Residential kits for eco-homes and rural dwellings, as it is a simple plug-and-play installations under a rainwater reservoir. 2. Portable treatment units for disaster relief or remote clinics, as it is self-contained PFC modules powered by solar-driven compressors. 3. In industrial pre-treatment, as concentrators to reduce salt load before reverse osmosis, cutting membrane fouling and energy cost. This work builds on and complements prior studies in 3 published journal papers as listed here. This innovation is invented based on and derived from a granted patent we have filed as shown here. For collaborations and inquiries, feel free to contact me at this email, and the original research paper can be accessed through this DOI link. Thank you for listening to our presentation.